This is a repair video or field repair video for the DS64. Digitrax announced that they would no longer repair the DS64 since the release of the DS74. I had 3 of the units that needed to go out for repair, but I never sent them out. So I thought maybe I'd try to repair them myself. Unfortunately, I didn't video the repair process, but it's pretty much straightforward, and I'll just go through and kind of show you the components and what you have to lift off and whatnot. Of the 3 units that I had, 2 of them were problems with the DC inputs, and 1 of them had the issue with the resistor that would overheat. I was able to repair both of them, and that's kind of what this video is, an overview of what's necessary or what's needed to repair the components. So here's the first unit, and this particular unit had the issue with the DC side of the board, and here you can see the 3 inputs, the power inputs, the external DC input, the track input, and then the DC input from the rear. Now you can see the run here. It actually goes around and then it meets here from the 2. These are the 2 common DC inputs. And what typically happens is if you take, let's say for example, the track input and place it on this DC input, it will blow out this component. This component is called a Schottky barrier diode. And what it does is it allows the current flow in one direction, and it blocks the other direction. This particular unit, what would happen is you would plug in the power supply and it would immediately go out. There's a green LED on the PS14s, and when that LED goes out, then that means that there's a short in the system. And that short ended up being right here at this diode. So I replaced this diode, and you can kind of see it's a bit of a shoddy soldering job. But the strategy that I took was I had 3 of the units, 2 of the same problem, so I thought I would recover the first 2 and then use the 3rd one as a donor board. So this diode is called an SCD14, but this diode here, which I replaced it with from the donor board, was an SCD34, and that was a later revision board, I think a revision number 4, and this is a revision 2 board, so that's why those components are different, but it still worked. This unit I was able to recover, test, and it's fully functional. Now this is the second unit that I did. It basically had the same issue, and then you can see here the diode here is replaced. So actually removing the diode, I had the tweezer soldering iron, so you just kind of pinch it, let it heat up, and then you pull it off. But on going in and resoldering this piece back on, I just used a regular soldering iron, and I just laid the soldering iron there and then tacked it on this side and then tacked it on the other side. The job's kind of shoddy, but it was just kind of a test to see on the board, so I wasn't really worried about the quality of the soldering. I was more interested in trying to get it repaired. Now this is the donor board. So what happened with the donor board here, I'll show you, I'll go over this is an SS14 diode, barrier diode, and I had that on hand, so I thought maybe I would go through the process and just try to recover this board fully by using what I had. So I placed these two diodes in. This unit was always working anyway from the DC side of or the DC aspect, but when I removed it, as a donor board, then it went down. But now I was able to restore it. So these SS14s I put in, and it powers up, the board functions. But the original problem with this unit is this resistor would get extremely hot. The heat would radiate to the point that it could melt the plastic. Now, this is the result of the warning that Digitrax puts in their manual, and that warning is about using a tortoise switch when the software or the firmware is set up for the snap switches, like the Kato or the Atlas switches, the solenoid switches. Now, what ends up happening is the tortoise switches draw so much current that it will either burn this MOSFET open or burn it short. And when it burns it short, then you could take a voltmeter and take measurements here, and you'll see 1 to 3 volts output, and that's because this diode is actually shorted. Now, when it goes to the point where it burns open, then this will no longer function, and you would turn the switch, and there would never be any voltage output at these terminals, at your output terminals. So I had a what they call a 2-channel MOSFET. I had one, it was kind of at a different spec. It was at a lower spec, and I thought I would just place that in and see if I could recover this board and prevent the overloading of the resistor. So I put this MOSFET in, and it ended up working. I could turn the switch, and then this resistor would no longer be overdriven. Now, the way the MOSFET works is there's what they call the gate, a source, and a drain. And this chip will apply a small current to the gate, which will then cause this to switch. And it would be a short, not a short, but it would actually complete the circuit, and then that would throw the switch. So any kind of that 2-channel MOSFET would fit, but there's a certain part number for these. Now, there's 2 arrays. This top array, I think, supports the snap switches, and then this bottom array supports the tortoise type switches. And there are 2 different part numbers, and I'll list the part numbers on the sheet, all 4 of the part numbers here, the diodes, and then the MOSFETs. So that's pretty much the issue. You can repair these yourselves. The difficulty is in the replacement of the components and the soldering process. Some of the guys will go in and cut these legs and then remove the bulk of the chip, and then come back with tweezers and a soldering iron and lift the other half of the legs off. So you can do that without the equipment. So fortunately for me, I have the hot air soldering stations, and with that, what you do is you blow hot air in the area, and the heat will then cause the solder to liquefy, and then you could just take the tweezers and pluck the chip off the board. These are a little difficult. That's why I think it's better to get this particular Schottky diode because it has these two ends, and it's a lot easier for you to go with the soldering iron and tack the two sides down, and then put in the solder and reflow the solder in. But you can use, what you got if you have just basic Schottky diodes like the big square ones here. So now the three sides that actually that you can have trouble with. The first side is the DC inputs here. Then you have the outputs that's associated with the MOSFETs. And then the third section of trouble is the local net ports. So the local net ports can go out because of these diodes here and here. There's 4 of them. And when these diodes go out, they could either drop the whole circuit and you have no access to the chip, or the diodes will burn it out or short out, and they will then cause noise to go across the local net ports. That's pretty much the areas that can go out. Now, the chip, you can have issues with the chip, and if that happens, then the unit is pretty much dead, because you would have to go in and have the chip and then be able to reprogram and write the firmware to the chip itself. And that's kind of more so a manufacturing process. So because you won't have that process, then the board would be pretty much dead. Now, the other components here, the probability of them going out is very low, unless you take the casing off and then go in and inadvertently knock something out. So there's not very many other issues that can have. So these are mostly the service areas that you can affect, and then also you can repair, is the DC power, then the MOSFETs here, the what do you call it? The switch outputs here, the control outputs. So this pretty much sums up the repair process itself. You can go on YouTube and kind of check out how the guys would go in and pull these chips out, and then resolder them. So now let's look at the chips themselves, or the components themselves. So this is the MOSFET that I pulled out, and then these are the barrier diodes. So I'll show you how to test them, or what to kind of look for. So you can take your meter and put the settings for the diode testing, and that's pretty much here. You can go in and turn your meter to this setting, then you hit the function, in this case. Here, the light's not showing that. So that right there is the setting or the function for testing the diode. And what happens is the meter will put out a small current, and that current will flow through the diode. And if you see the current flow, then you know the diode's good. Then you would switch polarity, and when you switch polarity, the barrier diode should prevent current from flowing through. So once you see that, then the meter will go OL, and you'll know that it's working. So in this case, here are the diodes, and these are the diodes that failed. So what I'll do is, just so you can hear the meter as I test. Here you can see that it's shorted. So with that short, that's what was causing the power supply to shut off. Now with the MOSFET here, the MOSFET has what they call a gate, a source, and a drain. And the gate is what triggers the MOSFET to operate. And when it operates, it allows the current to flow through the legs. So here, if you test the MOSFET itself, you can see that it's shorted out. And typically that shouldn't go short until there's a current actually applied to the gate. And that was what was causing the short. And that short would then draw current. And because the current, it was like 1 volt, 1.5 or 1.6 volts. It wasn't enough to trip this the unit, but it was drawing enough current that would cause the resistor to heat up. So once I repaired and put the good MOSFET in, that issue of the burning or the heating of the resistor went away. So that issue was resolved. So that pretty much sums up the process. You can do it, no doubt. It's not a big deal. It's kind of a good exercise in testing the components and repairing them. So here's the listing of the components. These are the data sheets. You can use them to find the cross-reference for some of the components that may be obsolete. Hope you enjoy the video. Subscribe, like, share, and hit the notification bell for the upcoming videos. Thanks a lot. Bye.